it's still don't shave December, so keep growing those beards.
What?
Alright, so first step, f of x turns into what letter? Y equals, now what is this called? Cube root. Cube root x minus 3 and then plus 7. Okay, and I'm solving this. Everybody, even by the window with the phone in our hand and the headphones in our ears, that's you. So x and y do what? Switch order, so x equals cube root, that's supposed to be a 3. X equals cube root y minus 3 plus 7. Okay, now what do I get rid of first? Plus 7 by getting rid of it with a minus 7. And it's going to go after the x. X minus 7 equals cube root of y minus 3. Now, I need to get rid of the cube root. What's the opposite of cube root? Not square root. But now, how do I get rid of a cube root? So, is everyone looking right here? Cube root, the opposite is a cube. So I take the whole thing on the left, cube it, the whole thing on the right, cube it. Yes. So when I cube root and cube, when those cancel out, now I have x minus 7 cubed equals y minus 3. Now my last step to get rid of a minus 3 is to do what? Add 3. So plus 3, that goes afterwards. So my final form, f inverse of x equals x minus 7 cubed plus 3. All right, now, it's been a while since we've actually done some notes. So we're going to do 3.4 notes today. Yes, record. If it's an emergency. Here we go. So first thing I want you to do is we need to fill out this table. So what I want you to do is graph 10 to the power of x and then write down the table. Okay, so let's fill this table together. Let's go to our calculators. So, calculator 10 to the power of x. So, graphing it, 10 carets right here, x. Now, does everyone see what that looks like? Okay, exponential function. Just a reminder, we got to have our heads up. We're not supposed to have any phones out. We're not supposed to have any headphones in our ears. Oh, and a reminder, we should not have headphones in our ears because this is brand new stuff, please. Now, Control T to get our table. And we're starting at -2. So let's write this down. This is part of the table on our notes. Let's write down -2.01, -1.1, 0.1, 110, and 100. Okay. Now, we should be able to graph that. -2.01. Now, 0.01 is barely above -2, so whatever. Okay, so that's my favorite response to me asking you to take your headphones out. However, it's all about taking it out, you know? Clear ear canals. Now, -1.1 is a little bit above -1. 0.1's right there, and then 110 is right there. We obviously cannot graph to 100. So we got these 4 points. They're kind of weird, but it's supposed to look like this. So it starts up here, comes down, and then it turns real quick, and it goes this way forever. Now y'all remember when it goes and barely touches that line? What's that line that it can't touch called? Starts with an A. Asymptote, okay? So I'm going to do it in blue, but you can draw yourself a asymptote. It cannot cross that line, for sure. Okay? Now today we're learning the inverse of an exponential, okay? So this is an exponential with a base of 10. What is the inverse of a exponential function? It's called a logarithmic. Say that, logarithmic. All right. So you might hear it called logs or logarithms, okay? But do you see how it actually says the word log, log, okay? So here's why this matters, okay? Sometimes your variable is in the exponent, so like x or y will be up top in the exponent, and you want to bring it down. Okay, so basically exponent brings it up, log brings it down. Okay, so it's always opposites. Exponential is opposite of log, log is opposite of exponential. Exponential goes up, log goes down. And I dressed perfectly for this today because look at me. What do I look like? Look like a lumberjack. No, with my flannel on and my no shave November beard, don't shave December beard on. You know, you can almost imagine me bringing in an axe, which I did not do because that would be wrong. And then chopping down some trees and making some logs. So that's what happens today. We're taking things down, making logs. All right? So what do I do with this table to get the inverse? What do I always do to get an inverse? Switch the order, flip it around. So can everybody flip this table around? Right? So let's do that. 0.01 right here. 0.1, 1, 10, 100. Okay. So once you flip it around, I want to plot these points. 0.01 is barely to the right, and then -2 is down 2. 0.1 is barely to the right, -1 is down 1. 1, 0 is right there. 10, 1 is over here. So you should get those 4 points, and then once again, we're going to graph them. Now this time, it's going up, it's going forever this way, and then it makes a strong turn, and it does not cross this vertical line. What's that called again with an A? Asymptote. All right. Now, do you see how those two are reflections across the diagonal line y equals x? Right? Like this diagonal line. Well, anyways, at the bottom here. Now, you're going to have to do these on your assignment and on the back of the notes. So, horizontal, okay? Look right here. This blue horizontal line crosses which axis? Which axis is straight up and down, X or Y? Y. So horizontal asymptote is always Y equals, and what point did it go through right there? 0. So Y equals 0 is my horizontal asymptote. It does not cross the horizontal line at 0, right? So, domain and range. Now you can see that this goes to the left forever right here. The question is, does it go to the right forever? And I'm telling you it does. Okay, it's exponentially going up by powers of 10 forever to the right. So domain from left to right is negative to positive infinity. You know what sounds like? That sounds like not my problem. Cool shirt. Now, range. How far down does this go? See how it doesn't cross 0? But it doesn't touch 0. So is that a parentheses or a bracket? What do you think? Bracket is when it touches. This does not touch. So this will actually be parentheses 0, and it goes up forever, right? You can see that with the arrowhead. So be careful. When there's a horizontal asymptote, the range is limited. Okay? So, vertical asymptote on the right one. Now, vertically, it does not go past what point right here? 0. But it goes through which axis? What axis is left or right? X or Y? Which is this one? X. So it's X equals 0. So again, horizontal asymptote is Y equals a number. Vertical asymptote is X equals a number. Write this down. So let's do domain. Domain. Now, how far to the left does this go? Can't go past this line, which is at 0. So, parentheses are a bracket. What do you think? Parentheses, because it does not touch. Okay? So, parentheses, parentheses 0, and it goes forever to the right to infinity. What do you think the range is? U. How far down does this go? So, positive? Down is positive? Alright, so negative infinity, comma, and how far up does it go? Now look right here. This looks like it's not, but it really is slowly going to go up forever. So it does go to infinity. So when it's the logarithmic function, the inverse of a exponential, that's when we have a horizontal asymptote and the domain is restricted, okay? Or it is, with an asymptote. Let's flip it over. Now on the back, this might be a little tough. We're going to work on this together. Please stay with me. Please stay awake. Please stay focused, okay? All right. We've done stuff like this before, but there's a new step involved, okay? This is just like the warm-up. Get the inverse, right? But you got to know how to get rid of an exponential, okay? So let's do this. First step, f of x turns into what letter? Y. So let's turn that into a y. Okay, so y equals 10 power x minus 2. And then, what do I do with x and y? I switch the order, right? So x and y switch places, right? So now it's going to be x equals 10 to the y minus 2. What should I do with that minus 2? Get rid of the loner, do the opposite. So yeah, plus 2 here, plus 2 here. Goes after that x. So now I'm left with x plus 2 equals 10 to the power of y. Now I need y to be by itself. So I need to get rid of the 10, but I also need to bring y down. Now, think about Mr. G the lumberjack standing here. How do I bring y down? The new thing for today. Logs. Remember? Lumberjack. Bringing it down. Cutting down trees. Logs. I'm telling you the answer is logs. So don't say divide. So, that's why on the front, the opposite of an exponential is logarithmic. Log. So, let me show you how to write this. This is the brand new step. Is everyone wide awake? Looking at this brand new thing we're doing today? Okay, because I can't teach you twice. Can't teach you the first time. Let's do it over here. Look over here. So, since there's a 10 in the base, here's what you write. Log with a little 10. That's log base 10. That's how you say it. Okay? Parentheses x plus 2. So I put a log 10 on the left. I'm going to put a log 10 on the right. Right? So equals log little 10, 10 to the power of y. Okay. Now, the reason why we did this is so that on the right side of the equation, the 10 would go away and the y would come down out of the exponent. So does everyone see? All I did was add log 10, log 10. Here's the magic. The log 10 and the 10 cancel each other out. Now I'm left with just the letter y. That's what I wanted. I just want y. On the left side, it's just log little 10 x plus 2. That's ugly. Let's try that again. Final form would be f inverse x log little 10 x plus 2. Okay. So that's kind of a lot, but you know the steps, hopefully. Okay. The only new step is to get rid of an exponent, you do a logarithm. Okay. We should be able to get a table for the original function, so let's do that. Let's go to new document, graph, and we're going to type this in, 10 to the x minus 2. 10 to the power of x, go to the right, minus 2. Is everyone able to type this in? Everyone knows how to type this in. Because you can type it in, hit enter, and then get the table. Now, does everyone see how this is shifted? Shifted down 3. You see how this horizontal asymptote is, down 2. And you know how I can tell? Because the equation says minus 2. So doesn't that make sense? It doesn't touch negative 2. Because it's been shifted down 2. So, let's do that. Let's make this table. So, Control T. And I need some points I can actually plot. So let's use these 4 right here. Negative 2, negative 1.99. Negative 1, negative 1.9. 0, negative 1. And then 1, 8. Okay? So again, you type it in, you hit Control T, get the table, and then we're going to plot these points, okay? Plot these points. So negative 2, negative 1.99 is almost there. Negative 1, negative 1.9. 0, negative 1. Oh, whoops. Back up. And then 1, comma 8. So this is coming down, and it does not touch that line. So real quick, horizontal asymptote. If you have a D value out here, okay, this is going to tell you the horizontal asymptote and the vertical asymptote number. Now see what you remember from the front side. Horizontal asymptote, is that x equals or y equals? What do you think? And if you forget, you can check it out on the front. Okay, but horizontal is y equals. Okay, so over here we're going to put y equals, and what's the change? What's the letter D value right here? -2. And you can see it on our graph that it does not go below -2. Okay. And then what do we do with that table to get the inverse? Flip it and then plot it. Same thing. So let's do that. -1.99, comma -2, -1.9, -1, -10, 81. Oh my gosh. All right, let's plot these. -1.99, -2, -1.9, -1, -10, 81. So it's coming this way, and then it's going straight down, and it's not crossing this asymptote. Now, what does it not cross? What's this x value right here? What's that value? What do y'all think? What's this x value right here? It's actually right at 2, -2, okay? The points were at -1.9 because they're getting close but not touching. But what it doesn't touch is -2. Do I put y equals or x equals? Vertical is different than horizontal, right? So instead of y equals, we're putting x equals, but it's the same number, -2, okay? Now, example 2, same idea. We're going to substitute y, switch the order, and all that good stuff. So let's do that. So this becomes y equals 10 to the x minus 4 on top. And then what happens with x and y? What do we do with x and y? Switch the order. Okay. Now, x and y switch. So it's y minus 4 up top. Now, what should I do first? What do you think? So you would think the 4, but it's in the exponent, so you can't touch it till it goes down. So first thing we need to do is bring everything down. We learned this today. How do I bring everything down? Chop it down like a lumberjack. And he's making the trees into what? Logs. You're so close. Logs, yes. So log base 10. Okay? So log lil 10 x on the left equals log lil 10, and then all this on the right. 10 y minus 4. I know that's a lot of layers. There's a 10 on the bottom. There's a y minus 4 on the top. There's a lot of junk there. Okay. But the reason why we do that is so that the 10 can cancel with the log 10. So log lil 10, then a 10, and then a y minus 4 up top. Okay. So the log 10 and the 10 go away. And now I'm left with log lil 10 x equals, and bring that y minus 4 down. All right, that's a lot cleaner, okay? So again, to bring something down out of an exponent, you have to use a log. Log, right? So, to get rid of the minus 4, last step, what do we do? Minus 4, what do we do? Plus 4 here, plus 4 here, and it's going to go after it, okay? So, final form, let's write it as f inverse x, bless you, log little 10 x, and the plus 4 goes after it, plus 4, okay? Cool. Now, we did all that work to get it in the inverse function, but let's go back to the original to get the table. Okay, so let's graph this. We got a new document, graphing. So the original formula was 10 to the power of 10 caret parentheses x minus 4. Hit enter. Okay, so I have this exponential function that's been shifted 4 to the right. Remember, the c value shifts left to right, and this one shifts to the right because it's a liar, right? So let's get Control T for the table. And let's use some of these points that we can actually graph. So 2.01, 3.1, 4.1, and 5.10. Let's graph these. So 2.01, 3.1, 4.1, and 5.10. And while we're at it, let's do the inverse. Just flip it around. Okay? So we have 0.012, 0.13, 14, 10, 5. Okay? So we wrote our table. We flipped the table around. Plot the points. Okay? So 2.01 is barely above it. 3.1 is barely above it. 4.1, and then 5.10. Okay? Now, here's where this can get confusing. Do you remember up here, we said this number tells us our asymptotes, this minus 2? Down here, you might think, hey, that minus 4, doesn't that tell us my horizontal in vertical asymptote, question mark? And I will say, no, it doesn't, okay? It's in the exponent, so that does not shift it up or down. That shifts it left and right, okay? So here's the deal. What is the asymptote? Where does this go? What value? What's this? 0, okay? So it goes through the y-axis at 0, so it's going to be y equals 0, okay? Let's plot the other points. 0.012, 0.13, 1,4, and 10,5. So it's going forever this way, and then it takes a sharp turn straight down. Okay, and once again, it doesn't go through 0. That's where it's crossing at the origin. So instead of y equals, it's going to be x equals 0. Okay, I know these are ugly, but that's how you do them. Exponential and logarithmic. Okay, one more example for these notes. Now this one's a doozy, so look at that. Look at all that. Oh well. All right, example 3. F of x becomes y equals negative 10 to the x plus 3. And once again, x and y switch. So x equals negative 10 power y plus 3. All right. Start solving this. What do I get rid of first? Get rid of okay, good. Get rid of the positive 3 with the minus 3 and a minus 3 that goes after the x, right? So now I have x minus 3 equals negative 10 to the power y. Now real quick, before I get to this y, and you know how we bring it down by now, hopefully, but how do I get rid of a negative? What's the opposite of a negative? Another negative. Here's what I mean. To get rid of a negative sign, you have to divide by a negative sign, a negative 1. Okay? So yeah, you want it to be negative divided by negative, so it'll cancel out. So it'll be positive, right? So here's the deal. Anytime you're trying to get rid of a negative sign, I think we've gone over this before, but you divide by negative 1. And the left side is also going to be divided by negative 1. Okay? All that does is change the signs, right? So the positive x is going to change into a, and then the negative 3 is going to turn into a. All right, so let's write that down. Positive x becomes negative x. Negative 3 becomes positive 3. That equals 10 to the power of y. Cool. Now, y is in the exponent. I want to bring y down, just like a lumberjack brings trees down and makes them into logs. All right, so that's what we're doing. We're logging it down. Here's how we write it. Log lil 10, parentheses, negative x plus 3, the left side, equals log lil 10, 10 to the power y, on the right side. It's the same equation on both sides. I just added a log 10 and a log 10. Okay? And why did I do the log 10? To get rid of the 10. That way y would come down. Timber. So log 10 and 10, cross them out. Y comes down. So let's just write the final form here. F inverse of x equals log 10 negative x plus 3. Okay. Now, we want to get the table, so we want to type in the original equation into our calculator and then get the table. So let's do that quickly here. So we have negative 10 to the power of x and then plus 3 is after it, so you go to the right, plus 3. Does everyone see how it flipped downward? Now it's over there, so hit Control-T for table. Let's get some points we can actually graph, and let's use these 4. -2, 2.99. -1, 2.9. 0, 2, 1, -7. So -2, 2.99, almost a 3. -1, 2.9, almost a 3. 0, 2, 1, -7. You can plot those 4 points like that. Okay, and it's going to look like this. It goes up, takes a sharp turn, and it does not cross that line. That is my horizontal asymptote, which is always going to be y equals, and remember, my d value right here, that's my horizontal and my vertical asymptote. Okay? So, the number I'm using for this right here is what? What is that? 3. So y equals 3. That means my vertical is going to be the same, except instead of y equals, it's going to be x equals. All I got to do is flip this table. 2.99, -2, 2.9, -1, 2, 0, -7, 1. Plot those real quick. 2.99, -2, 2.9, -1, 2, 0, -7, 1. So this one's going this way, takes a sharp turn, and it does not touch that vertical line at 3.